Welcome to a geometry video that is for revision for a quick reminder about similar triangles this time. What are the characteristics of similar triangles? Well, what we're going for overall is matching sides are in the same ratio. They don't have to be equal to each other, but they have to be in the same ratio. And matching angles will be equal in similar triangles. So the three tests for similar triangles are SSS. Now, they're that corresponding or matching sides are in the same ratio. So if one side is the half of the other side that's matching it, then another angle on the same triangle will be a half of its matching side, that sort of thing. So the sides are in the same ratio. If it passes that test, it's similar triangles. Also, if two sides are in the same ratio, two pairs of sides are in the same ratio, and the included angle, this would be the included angle in between these two sides we're talking about, are also equal, then we've got a similar triangle situation on our hands. And the other one is AAA. If there are three matching pairs of angles and they're exactly the same size as each other, then we have similar triangles scenario. So that guides our proving of similar triangles. One of those three tests has to be passed in order to establish that pair of triangles is similar. Here we have two triangles. ABC, which is that top triangle there that goes like there. And then we have another triangle, ADE, which is the big triangle. It's kind of overlapping the top triangle there. I'll do this one in green. So there are our two triangles there. And we're trying to show that they are similar to each other. Sides in the same ratio, angles being the same, all that sort of stuff. So we'll see what, we'll add together pieces of geometrical information and see if we've got enough information to prove that those two triangles are similar to each other. First of all, we notice that if those two side triangles are overlapping each other, they have a common angle up there. So that we can establish straight away that that angle is common and therefore equal in both of those triangles. So that angle is on the small triangle and on the bigger version as well. So it's common, and we say the reason why we know that is it's given. Another word we could use there is data. It's the data from the question. And we've established an angle geometrical statement there, so we're going to put an A at the end there in red just to show that. Let's piece together some more information that we have here. Now we're saying here on this line that angle ABC, just here, angle ABC, is going to equal angle ADE here. Now I'll get my red pen back up and just show you. We're using the reason here as corresponding angles in parallel lines are equal. So you can see if we extend the line here, we have a parallel line going across there, another parallel line going across there, and we have a transversal that goes down there. So we can use those parallel lines cut by a transversal rule, those relationships there, and we have those corresponding angles that are equal. So that's the rule we use there to establish a second angle statement that we are piecing together here. Okay, we have another statement we could make in a similar way on the other side of the triangle, I suppose. Angle ACB, this one here, is equal to AED, this one here, for exactly the same reason. It's just on the other side of the parallel lines and another transversal there. So we've used the corresponding angles are equal in parallel lines rule again to establish a third angle statement. And therefore we have enough information now to say that triangle ABC, and this is the symbol here for is similar to, three vertical lines, is similar to triangle ADE. And the reason we know that is that we've just added up enough information. We've established enough information to pass the AAA test. We have three angles on one triangle matching exactly three angles on the other. So now it is possible, because there's some numbers here, 3 and 4 and 6 and 14, we are actually able to prove these two triangles are similar using a different rule. The SAS rule would have worked nicely there as well, but it's a bit trickier, so I stuck to the AAA test for similar triangles. So that's just a model there. You'll notice that we make three statements and they kind of add up to passing that test there. So it's the test, if you put one fact on each line, that sort of guides our setting out. and that allows us to know how much information is enough to establish that one triangle is similar to the other. Alright, that's a quick rundown of similar triangles as a bit of a reminder from your classwork, so I hope that revision helps. peterblakemaths.com. Catch you next time. Thanks for listening.